Hi, section 2.3 is talking about the inverse trigonometric function. Before we start talking about the inverse trigonometric function, we need to talk about the properties that the function must have to have inverse for all functions. First of all, we say any function that wants to have an inverse must be one-to-one. What does it mean one-to-one? One-to-one means for every y value in the function, we must have only one x values. Or if we have a graph like this one, we can say this function can be one-to-one if for every one y value must have one x value, or we can do the horizontal line test. And if I do the horizontal line test, and if I graph a horizontal line, this line must cross my function at maximum 1 point. But right now you see that this line is crossing at 2 point, which means that this function is not one-to-one. And if it's not one-to-one, we cannot find an inverse for this function. We do the same for trigonometric function. So you know that the trigonometric functions are usually like waves, something like this. But the question is, are they one-to-one? Let's do the horizontal line test. If I graph a horizontal line, and this line must cross the function at only 1 point, or at most 1 point. But right now you see that this line is crossing at 1, 2, 3, 4, maybe oh, infinitely many points. So, which means that since the trigonometric functions are repeating functions, they are not one-to-one. So we cannot find an inverse for them. So what should we have to do? We need to restrict the domain. Right now in this picture, you see the graph of sine, and if you do the horizontal line test, it shows that the function is not one-to-one. And if it's not one-to-one, you cannot find an inverse. But if you want to find the inverse for this function, you need to restrict the domain. That means instead of looking at the whole graph, only look at the graph from negative pi over 2 to pi over 2. Only look at the graph from this point to this point. That means only look at the function from just in this red part. That's it. And if you look at this part of the function only, this part is one-to-one, because if you do the horizontal line test, it only crosses at 1 point. And then you can find the inverse for the sine function. So for all trigonometric function, to have the inverse, we need to restrict the domain. But the restriction is different. For sine, we always restrict the domain from negative pi over 2 to pi over 2, because we need to find the part of the function which is one-to-one. And for sine function, we look at the graph of sine only from negative pi over 2 to pi over 2. How do we show the inverse function? By sine with a -1 on top as an exponent, but that number is not an exponent. And we call this one the sine inverse. We say the sine inverse of x. Okay, so remember this -1, it's a notation to show the inverse function, it's not an exponent. And since we restrict the domain of sine to have an inverse, and we know that for every functions, when we have two functions, for example, I have a sine function and I have the inverse of sine. We always know that whatever is the domain of this function, that should be the range of the other function, and the range of this function is the domain of the inverse function. So what's the domain of sine function? We restrict the domain. So we only look at the domain from negative pi over 2 to pi over 2. So we say the range of the inverse function must be from negative pi over 2 to pi over 2 as well. That is one of the uh, characteristic of the inverse function. When we have a function and its inverse, the domain of the function is always the range of the inverse function and vice versa. And what's the range of sign? When you replace the numbers from negative pi over 2 to pi over 2 for x, what number you may get for y? The range of sine function is always from negative 1 to 1. There is no way we can get any other numbers, more than 1 or less than negative 1. And it doesn't matter what numbers we replace for x, the range is always from negative 1 to 1, which means the domain of the inverse function is also from negative 1 to 1. And you need to know that every point that we have on the function, for example, if I have a point of x and y in my original function, that point in the inverse function is y and x, which means the x and y in the inverse function always switch. If you have a point of, for example, 0 and 1 in your original function, you will have the point of 1 and 0 in the inverse function. And if we have a y equals sine inverse of x, which means that the sine of y must be equal to x. So try to understand the inverse function and try to understand which one of the x and y is a number, which one is an angle. There is a difference. When I have y equals sine x, x is an angle because trigonometric functions are always for the angles. So we plug in an angle for x, but we get a value for the sine of that angle. We just get a number, a value for the sine of that angle. But when we say the sine inverse of y equal to x, which means you plug in a value inside the parenthesis for sine inverse, and the answer that you get must be an angle. Okay, so for the original function, we always plug in an angle for the x, and we try to find the sine of that angle. But for the inverse function, we always have a value, and when we find the sine inverse of that value, we get the angle. That's a difference. Okay. And if I want to give you an example, I can also say, for example, I say that the sine of 30 degree is 1/2, which means that the sine inverse of 1/2 is 30 degree, or pi over 6. So it's better to, instead of showing in degree, show it in radian form. So sine inverse of 1/2 means find an angle that the sine of that angle is 1/2, and that angle is 30 degree. And in some books or notes, you may see instead of sine inverse, you may see they show as an arc sine. That's the same. When we say sine inverse of x, you can also say the arc sine of x. Arc sine of x means an arc which the sine of that is x. Because the length of the arc in the central angles is exactly the same as the central angle. And if you want to compare the graph, this one, the right one, the left one, sorry, is the graph of the sine, which is restricted from negative pi over 2 to pi over 2 only. And if you find the inverse of this part, you get the right one, the blue graph. And as I said, if you have a point pi over 2 and 1 in your original function, you will have a point of 1 and pi over 2. We switch x and y to find points in an inverse function. And we can also say that always for graphing an inverse function, we can graph reflected about, we can reflect the function about the line of y equal x. This line is the line of y equal x. And you know that this purple graph is your sine function. And if you reflect this purple one about this line, it gives you the blue graph. And reflect means whatever is the distance from any point of this purple function to this line, we need to have the same distance on the other side of the line. So you have two different ways for graphing inverse functions. One, you can switch the points, switch the x and y of the points, and then graph the inverse function, or you can find a reflection about the y equal x. We have the same properties for the inverse cosine as well, because you know that the cosine function is not also one-to-one function, because if I do a horizontal line test, it doesn't pass the test, and it crosses in many points, not only one point. And what do? We need to restrict the domain, and to restrict the domain for cosine, we restrict it from 0 to pi, because this part of the cosine function is a part that's one-to-one, and we can find the inverse for cosine from 0 to pi. Again, if we have the two functions, y equal cosine x and y equal cosine inverse of x, so the domain of cosine is the range of inverse cosine, and the domain is restricted from 0 to pi, so the range of the inverse cosine is also from 0 to pi. The range of the cosine is always from -1 to 1, so the domain of the inverse cosine is also from -1 to 1. And knowing the range helps me to find the exact value when I'm finding the cosine inverse of any angles. And I will show you in the next slides how we need to know this restricted domain. Because that restricted domain, that's exactly the range of the cosine inverse or sine inverse, and that tells me that if I want to find the exact value of the inverse function, I need to know that what value I need to find, because we have restricted range or restricted domain. And this is the graph of the cosine, because the purple one on the left one is the graph of cosine, which is restricted from 0 to pi, and the blue one is the graph of cosine inverse by switching all the points, switching x and y of all the points. And if you want to use the reflection property, you can reflect the graph of cosine, which is this blue one, above this line, and it gives you the cosine inverse. Now the question is how we can find exact value of the inverse sine and inverse cosine. So we said that we restricted domain for inverse sine. Okay, that means only the x values from -π/2 to π/2 can be acceptable. Okay, and if I want to show in a unit circle, -π/2 in the negative direction, that means from 0 to -π/2 and 0 to π/2. That means we only need angles on this part of the unit circle. But the negative angles from 0 to -90 and positive from 0 to +90. So we cannot have any angle which is 120 or 150 or 180 for inverse sine, because we have a restricted domain. So I created a table here for you for all of the angles from -π/2 to π/2 with the sine value. And having this table helps you to find the exact value of the inverse sine when in next examples. Let's find the exact value of the sine inverse of √3/2. Okay, what's the sine inverse of √3/2? I told you when you have a sine inverse of x which is equal to y, this is the value and the answer of sine inverse must be angle. If you want to find the sine inverse of root 3 over 2, that means this is a value and you want to find an angle. Let's give it a name. For example, we can set it equal to theta. Theta is my angle. I can say that the sine inverse of root 3 over 2 is equal to theta. Okay, what does it mean? It means I'm looking for an angle theta, which the sine of that angle is a root 3 over 2. So I'm looking for an angle which the sine of that angle is root 3 over 2. Okay, so now that table helps me to find the angle. If I go back to that slide, can you tell me which angle on this table, the sine of that angle is root 3 over 2? The sine of what angle is root 3 over 2? It's pi over 3. Yeah, so the answer is pi over 3. So you can say the sine inverse of root 3 over 2 is pi over 3. And I told you this must be an angle. And pi over 3 is an angle. It's not only a value. And also we need to pay attention that the angle must be from negative pi over 2 to pi over 2 only. And pi over 3 is indeed that interval. You cannot, have any other angles that is not in that range. For example, we want to find the exact value of the sine inverse of negative root 2 over 2. Again, we know that the sine inverse always gives us an angle. Okay, so if you set it equal to an angle, for example, angle theta, so in step 1, I set that equal to an angle. So if the sine inverse of negative root 2 over 2 is equal to theta, I can rewrite this one in form of a sine, because I know that I'm looking for an angle theta, which the sine of this angle is negative root 2 over 2. So the sine of theta must be equal to negative root 2 over 2. Now it's time to check the table. The sine of what angle is negative root 2 over 2? The sine of negative pi over 4. So the final answer is negative pi over 4. If I look at this table only includes a number from negative pi over 2 to pi over 2. So any number from this table, you don't need to check if it's an interval. But if you're not looking, for numbers, you're not looking at this table to find numbers, just make sure that you pay attention that the angle that you are finding, it's between negative pi over 2 to pi over 2. Because we may have any other angles in the third and fourth quadrant that are not, that the sine is negative root 2 over 2, but they are not in this restricted range. And we do the same for cosine. For cosine, I created a table from 0 to pi because we know that the cosine, the domain of the cosine restricted from only 0 to pi, and I found the cosine of all angles from 0 to pi to make it easier for myself. Now, if they ask me what's the cosine inverse of negative 1/2, so first of all, you say the answer for the cosine inverse is always an angle. If you set it equal to angle theta, which means that you are looking for an angle theta, which the cosine of theta is negative 1/2. Okay, the cosine of what angle is negative 1/2? The answer is 2 pi over 3. Next example. What's the cosine inverse of negative root 2 over 2? Okay, I know that the answer for cosine and sine inverse is always an angle. So I know that the cosine inverse of negative root 2 over 2 is an angle, like theta. You can give it a name. And I'm trying to find the angle theta, which the cosine of theta is negative root 2 over 2. That's the meaning of the cosine inverse. Now I need to check the table to see the cosine of what angle is negative root 2 over 2. And the answer is 3 pi over 4. So the answer is theta must be 3 pi over 4. So the answer for this one is 3 pi over 4. We have the same situation for the tangent and cotangent as well. If you look at the graph of tangent function in this picture, you see that the tangent is also not one-to-one. So we are going to restrict the domain, but this time restrict the domain only from, it's similar to the sine. We restrict the domain from negative pi over 2 to pi over 2, but the difference between this one and the sine function is that for the sine function, we restrict the domain from negative pi over 2 and pi over 2, including them. But for tangent function, we restrict the domain from negative pi over 2 to pi over 2, but not including the negative pi over 2 and pi over 2, because we know that these 2 points are asymptotes in the tangent function, so they cannot be in the domain. So that's why we keep a bracket, which means negative pi over 2 and pi over 2 is also included, but if you put parentheses, means they are not included. So if you want to have the both of the tangent and tangent inverse and then compare the domain and range, we said for the tangent we need to restrict the domain. So the domain of tangent is just from negative pi over 2 to pi over 2, which means the range of the inverse function is negative pi over 2 to pi over 2, not including it. And the range for the tangent function, so for tangent and cotangent, we don't have any restricted value. We can have any numbers. It's not like sine and cosine that we say the range is always from negative 1 to 1. For tangent and cotangent, the range is from negative infinity to positive infinity. We can get any numbers. And it's possible if we get even numbers more than 1 for tangent and cotangent. And therefore, the domain of the inverse function is negative infinity to positive infinity. So for the inverse function, you can have any number here for x. Okay, we don't have any restriction. And the same for cotangent. Cotangent also must, it's not one-to-one, so we need to, that's still the graph of the tangent. And for cotangent, we also restrict the domain. Cotangent is similar to the cosine. So if we have the graph of cotangent and the inverse of cotangent, we restrict the domain of cotangent from 0 to pi, but the difference is that for cosine, we restrict the domain from 0 to pi, including 0 and pi, but for cotangent, we don't include 0 and pi because 0 and pi are the asymptotes. So the range of the cotangent inverse is also from 0 to pi. And no restriction for the range. We can get any number for the range from negative infinity to positive infinity. So the domain of inverse function also can be any number from negative infinity to positive infinity. For cosecant, also, we need to restrict the domain. And to restrict the domain for cosecant, you have the domain in two parts. One part is from negative pi over 2 to 0, one part from 0 to pi over 2. So if you remember, for cosine is the reciprocal of the sine. For sine, we say we restrict the domain from negative pi over 2 to pi over 2, including them. For tangent, we said, again, from negative pi over 2 to pi over 2, not including them. For cosecant, we say the domain will be restricted again from negative pi over 2 to pi over 2, including them. except 0. We cannot have 0 in this interval. So we need to remove 0 out of this interval because cosecant is 1 over sine, and sine is in the denominator and cannot be 0. And the denominator cannot be 0. So to remove 0 out of this interval, if I want to show on the number line, if 0 is here, negative pi over 2, positive pi over 2, you can have all these numbers except 0. So you can rewrite the interval as a separate interval. You can have the from negative pi over 2 to 0 and from 0 to positive pi over 2, which means you are removing 0 out of that interval. So this is a restricted domain for cosecant. And if you remember the range, we said since the range of the sine and cosine is always from negative 1 to 1, and we always graph the cosecant and secant above and under this function. So this part between negative 1 to 1 cannot be a part of the range. So the range of the cosecant and the range of the secant can be any number less than negative 1 or more than 1. And you can rewrite this as an interval of from negative infinity to negative 1 and from 1 to positive infinity. And these are the domain and range of the cosecant. And for cosecant inverse, we switch domain with the range. So the range should be the domain of the cosecant inverse, and the domain should be the range of the cosecant inverse. A similar strategy for the inverse secant. Since secant is 1 over cosine, so for secant, the domain is restricted like cosine from 0 to pi, but the only thing that cannot be in part of this domain is what number makes this denominator 0. And the number that makes the cosine 0 is pi over 2. So I need to remove pi over 2 from this interval. And to remove that one, I can rewrite as a two separate interval, and I can say the domain is from 0 to pi over 2 with the parenthesis, which means not including pi over 2, and pi over 2 to pi. So we remove pi over 2 because pi over 2 cannot be in the domain, because pi over 2 makes a denominator or make cosine 0. And for the range is exactly the same as the cosecant. The range is all real numbers except the interval of negative 1 to 1, which means negative infinity to negative 1, and 1 to positive infinity. Okay. And you can see the picture of all inverse functions here in these slides with the restricted domain and range. So to find the exact value of the inverse tangent and inverse cotangent, we follow the same strategy as we did for the sine and cosine. Since for tangent, we restricted the domain from negative pi over 2 to pi over 2, not including pi over 2 and negative pi over 2. I have created a table from negative pi over 2 to pi over 2, but I didn't put those numbers there in the table because they are not including. And then find the tangent of all of those angles, possible angles that we can have in that interval. And I'm going to use this one to find the exact value of the tangent inverse of any number. For example, if they ask us what's the exact value of tangent inverse of negative 1, so the tangent inverse of negative 1, again, we know that any inverse function gives us an angle. So that means the tangent inverse of negative 1 should be an angle. If that angle is called theta, it means that the tangent of theta must be equal to negative 1. And I'm looking for an angle theta, which the tangent of that angle is negative 1. And I remember that the domain is restricted, that means it must be from negative pi over 2 to pi over 2 only. If I look at my table, so the tangent of what angle is negative 1? Yes, it's negative pi over 4. And then negative pi over 4, that's exactly within that interval. So the answer is negative pi over 4. What's the exact value of tangent inverse of 0? Again, tangent inverse gives me an angle. If that angle is called theta, I'm looking for an angle theta, which the tangent of that angle is 0. So let's look at the table. The tangent of what angle is 0? Exactly 0. So the answer must be 0. So the answer for the tangent inverse of 0 is also 0. Now let's find the exact values of the inverse cotangent, secant, and cosecant inverse. So what's the cotangent inverse of 0? So you know that the answer for all of them is an angle. I remind you every time because I don't want to just write 1/2 or 3/4 because the answer must be an angle. Angle must be in radian or degree form. So you must have your answer in like pi over 2, pi over 3, negative pi over 6, negative pi over 3, but you cannot say that the answer is 1/2. Okay, so your answer must be an angle. And that angle is an angle which the cotangent of that angle must be 0. Now the question is, the cotangent of what angle is 0? I don't have a table right now to use, but I know the cotangent is always cosine over sine. And if the cotangent is supposed to be equal to 0, it means that the fraction must be equal to 0. And the only time a fraction can be equal to 0, it's when the numerator is 0. So it means that the cosine must be 0. Okay, cosine of what angle is 0? If you look at the unit circle, that's a cosine axis, and you know that at this point and this point, the cosine is 0. But which one is acceptable? Because we have a restricted domain. We know that we cannot have any point that we want. So based on the restricted domain for cotangent, which is from 0 to pi, not including 0 to pi, that means you need to find an angle somewhere on these two in this part of the circle. And this is my final answer, which is pi over 2. So the cotangent inverse of 0 is pi over 2. Okay, let's look at next example. Next example says, what's the cosecant inverse of negative 1? I know that the answer must be an angle, and I'm looking for an angle which the cosecant of that angle is negative 1. Okay, how do we know what the cosecant of what angle is negative 1? I don't have any table for cosecant, but that's fine, because we know that the cosecant is 1 over sine, and you know that the 1 over sine must be equal to negative 1. We can use some identities. And if you want to find the sum from this equation, you will get sine of theta must be equal to negative 1. Okay? Sine of what angle is negative 1? If you look at unit circle, that's a sine axis, and the sine is 0 here, is 1 here, and negative 1 here. So the sine of what angle is negative 1? This one. Okay, now the question is this point negative pi over 2 or it's 3 pi over 2? Which one? Since we know that we have restricted the domain for cosecant, and the cosecant the domain for cosecant is just from negative pi over 2 to pi over 2 except the 0. So it should be an angle in the fourth or an angle in the first quadrant. So I cannot say the angle is 3 pi over 2 because 3 pi over 2 is an angle in the third quadrant. So I can say the cosecant inverse of negative 1 is negative pi over 2. Okay. Now part C. What's the secant inverse of negative 2? Again, we know that this is an angle data, and I'm looking for an angle which the secant of that angle is negative 2. I don't know. I don't have any table for secant, but I know that the secant is 1 over cosine. If I replace 1 over cosine instead of secant of data, I can find the cosine from this equation. To find the cosine from this equation, you can do the cross multiplying and then divide by negative 2, and it gives you that the cosine of data must be equal to negative 1/2. Now you have a table for cosine. For sure, you can find an angle, or you can remember the cosine of what angle is negative 1/2. I know that the secant inverse, the secant domain is restricted from 0 to pi, because that's the reciprocal of cosine. So the secant domain must be somewhere between 0 to pi except pi over 2 in between. That means you are looking for an angle in one of these quarters, in the first quadrant or the second quadrant. Now, since the cosine is negative, then for sure, that means the angle must be in the second quadrant because the cosine is negative on the second quadrant. Now, what's the answer? The cosine of what angle is negative 1/2? It's 120 because the reference angle for that is 60. So 120 in radian form is 2 pi over 3. So the secant inverse of negative 2 is 2 pi over 3. So that's why it's important that you know that all of these functions domain, what's the restricted domain for all of them. Now we want to see how we can find the composition of two functions. When we talk about the composition function, we are talking about the function that is inside of another function. And in algebra, we call them FOG, if you remember it. FOG, or the composition of two functions f and g, it's exactly the same as f of g of x. And it means that the output of one function is the input of another function. What do we mean? When we talk about the function g, when we say g of x, the x is input in this function, and g of x, or the y, is output. When we talk about f of g of x, the input is whatever is inside the parentheses. So the input is g of x. And that means that the output of function g is the input of this function f. That is what the composition function means. Now we have sine and sine inverse that they are, which the output of this function is supposed to be the input of this function. And you know that the output or the answer for the inverse function is always an angle. And you want to find the sine of that angle. For example, if I say, what's the sine of sine inverse of 1/2? What's the sine inverse of 1/2? The answer must be an angle for sure. The sine of what angle is 1/2? So the answer is pi over 6. Okay? So if you replace this by pi over 6, now you ask yourself, what's the sine of pi over 6? Again, is 1/2. What does it mean? It means the sine and sine inverse, which they are inverse function, they can cancel each other. So the sine and sine inverse can cancel each other. Sine inverse and sine can cancel each other as long as the angles, the answers, the x are in those intervals. If the sine is first, the sine inverse is the inner function. The x must be a number between -1 to 1 because this is a value, not an angle. But if the sine inverse is out and the sine x is the inner function, this is an angle, so the angle must be from -π/2 to π/2. When we have cosine and cosine inverse, when you have cosine inverse as an inner function, you have a value inside, and that value must be from -1 to 1. Otherwise, they cannot cancel each other. And if you have cosine as an inner function, you know that should be an angle, and that angle must be from 0 to pi because you know the restricted domain for the inverse function. And the same for tangent. Tangent inverse, the x can be any number because we don't have any restriction for the range of the tangent function. But if the tangent is the inner function, the x must be from -π/2 to π/2, not including them. If you have an angle which satisfying, it's exactly on that interval, you can easily cancel sine and sine inverse, cosine and cosine inverse, tangent and tangent inverse, and just put that as a final answer. But if the angles are not in those restricted intervals, you need to find them separately. You need to find the answer for each function separately. For example, we want to find the exact value for part A. We have a cosine of cosine inverse of 0.07. When we have cosine inverse, for cosine inverse, it must be a number here. And that's a number. And that number must be, for sine and cosine, is from -1 to 1. Is 0.7 between -1 to 1? So the answer is yes. If it's between -1 to 1, it's in that interval, that means cosine and cosine inverse cancel each other. So the final answer is 0.7. Part B, sine inverse of sine of pi. When you have sine as the inner function, this must be an angle. And the angle for sine must be from -π/2 to π/2. Is this angle, or is pi between -π/2 to π/2? No. If the answer is no, that means these two cannot cancel each other. Sine and sine inverse cannot cancel each other, and I need to find the answer for each of them individually, separately. So how do we find the answers for each? So let's start with the inner function. What's the sine of pi? So the sine of pi is 0. Now you say, what's the sine inverse of 0? You replace the 0 for that. So what's the sine of inverse of 0? What's an angle that its sine is 0? So the answer is also 0. So the final answer for this is 0, is not pi. So not in this. Since pi is not in this domain, we cannot easily, cancel sine by sine inverse like what we did in part A. So we need to find the inner function first and then the outer function. The inner function, the sine of pi is 0, and the sine inverse of 0 is 0 as well. For part C, we want to find the cosine of cosine inverse of -1/2. Since the inner function is cosine inverse, that means this must be a number. And numbers for cosine always must be between -1 to 1. Is -1.2 between -1 to 1? No, it's not in that interval. If it's not in that interval, you cannot find an answer for that. Because you may be able in part B to find the sine or cosine of any angles, even if it's not in that interval. But for sine and cosine inverse, if the number is not in that interval, you cannot do anything. So negative 1.2 is not included in the domain. So that's undefined. We cannot find any answer. There's no solution for this. Next example. Let's see what's the exact value for part A, the sine of tangent inverse. Okay, this time we have two different functions, sine and tangent inverse. So for sure, they're not canceling each other. So it means that we have to find the inner function first and then outer function. So the inner function is the tangent inverse of 7/4. And you know that the answer for any inverse function is always an angle. Let's call it theta. So we say that the tangent inverse of 7/4 is theta, which means the tangent of that angle theta must be 7/4. So this is the information from the inner function. Inner function tells me, since the answer for tangent inverse is an angle, I'm looking for an angle which the tangent of that angle is 7/4. And if that's theta, this is called theta, I'm looking for the sine of that angle. So the question tells me if the tangent of an angle is 7/4, you find the sine of that angle. But the question is, I don't know what angle's tangent is 7/4. I don't have 7/4 in my table. So anytime you face numbers like this, which is not on the table value, try to use right triangle properties. So easily. So you know the tangent is always opposite over adjacent. So let's make a right triangle. And that's my angle. I know that for this angle, the opposite is 7, the adjacent is 4. Okay, that's the information that I have so far for my right triangle. But I'm looking for the sine of that angle. And I know that the sine is always opposite over hypotenuse. I know the opposite, which is 7, but I don't know the hypotenuse. So I need to find the hypotenuse. I know the Pythagorean theorem, and I can just use the Pythagorean theorem to find the hypotenuse. So 7x squared, which is 49, 4x squared, which is 16, 49 plus 16, it's 65. And if I take the square root from the both sides, x must be equal to square root of 65. Okay, so the answer is 7 over the square root of 65. And since we never leave fractions with the radical in the denominator and we need to rationalize them, if we rationalize the square root of 65, the final answer is 7 root 65 over 65. So that's the final answer for part A. So anytime you had numbers that you had no idea what's the tangent, what's that angle, just use the right triangle and use the given information, which is tangent in this case, and find the information that it's asking to you. You don't need to find everything. You just need to find the sine of that angle. You don't even need to find the angle because we don't know how much is the angle. I just need to know what's the sine of that angle. Do the same for part B. Again, we have a cosine of sine inverse of 7/9. So cosine and sine inverse for sure are not canceling each other because they are not inverse of each other. So I'm going to start from the inner function, and my inner function is an inverse function, and the answer for every inverse function is an angle. And I know that the sine inverse of 7 over 9 is equal to an angle named theta. And I'm trying to find that the angle which the sine of that angle is 7 over 9. And if this whole thing inside the parenthesis is called theta, I'm trying to find the cosine of that angle. This is what I want to find. It looks like that we have an angle, the sine of that angle is 7 over 9, and they're asking to find the cosine. Okay. We can use trig identities or we can use right triangle properties. So again, we can create a right triangle. So you know the sine is given to you, and the sine is opposite over hypotenuse. That means if that's your angle, the opposite is 7, the hypotenuse is 9. But for cosine, you need adjacent. So you need to find this side first. And to find this side, I need to use the Pythagorean theorem. So x squared is 81 minus 49, which is 32. And if I take the square root, I will have the square root of 32. You can simplify because 32 is 2 times 16, and 16 can be out as a 4, so we have 4 root 2. Now, the question was asking what's the cosine of that angle? So the cosine is always equal to the adjacent over hypotenuse. And the adjacent is 4 root 2, and the hypotenuse is 9. So that's the final answer. And the last example, which says find a simplified expression for this. Why it says find a simplified expression? It doesn't ask you find the exact value because we have x here, and the x doesn't let me, if I don't know what the value of x is, I'm not able to find the exact value, but I can find a simplified expression. But we do the same. So we want to find the cosine of sine inverse. I know that the inner function, sine inverse, it's an angle. And I'm trying to find the cosine of that angle. So far I know that the sine inverse of x over 3 is equal to an angle theta, which means I'm looking for angle theta, which the sine of that angle is x over 3. So the sine is given to you, and they're asking to find the cosine. Can I still use the right triangle? Yes. So we will have a right triangle again because sine is opposite over hypotenuse. That means if the angle is here, the opposite is x, the hypotenuse is 3. But you want to find the cosine, which is adjacent over hypotenuse. I need to find adjacent. This, I call it A. So my goal is finding A. X stay the same x. Okay? So using the Pythagorean theorem, 3 squared must be equal to x squared plus a squared. Right now, the only variable here is a. I don't mind that if the x is also variable. Just looking at the x as a number. So to find the a, you need to move x squared to the other side. Then you need to take the square root from both sides. But you know that anytime we take the square root, we need to have a plus and minus, especially in this case that we don't know what the x is. But the question tells me that the x must be a number between -3 to +3. And I also know that since the sine inverse is given to me, the domain of sine is, the domain of restricted sine must be between -pi/2 to pi/2. And if you look at unit circle, negative pi over 2 to pi over 2 means these two quarters. And in these two quarters, the cosine is always positive. So that's why we keep this one only positive. Okay. So now I can find the cosine, which is adjacent square root of 9 minus x squared over hypotenuse, which is 3. So the simplified expression that we found for that, so we can say the cosine of sine inverse of x over 3 should be equal to square root of 9 minus x squared over 3. That's it. I still get an expression based on x because we don't know what the values of x.